want to welcome each and every one of you from your different respective homes, and I want to thank each and everyone who has been calling me, talking to me, and asking me about how the classes are going to be attended. Are we going to have classes? All those things. That's a very good positive effect from you guys, and I want to thank each and everyone. And I wanted to tell you that starting from now on, we shall be having classes like this. I'll be recording videos and sending them to you via WhatsApp. So, the first thing today is I want to show you what analog and digital signals are. We have heard about analog and digital everywhere. Analog, digital, we are transforming from analog to digital. There are many things which concern this. So, let's start with the different meanings of analog and digital. So basically, what analog and digital, the difference is analog is designed in a way that uh, information is traveling through wavelengths. Basically, sound. So it travels through the air through sound. So that's basically that's where analog bases most of its information. Then digital is basically mostly wired electronic devices, ranging from phones to all the other appliances we are having, smart televisions, laptops, uh, desktops, high-end desktops, all those things. So analog and digital are different types which are mainly used to carry data from apparatus to another. Analog signals are continuous wave signals that change with the time period, whereas digital is a discrete signal in nature. So basically they're telling you the wave signals keep on changing for analog, but for digital it is discrete, as in there are only two types of changes. It's either on or off. So the main difference between analog and digital signal is analogs analog signals are represented with the sine wave, whereas digital signals are represented with square waves. So they're trying to tell you that for the analog, I have an image here. For the analog, we're seeing this sort of wavelength, wave appearance. So this wave appearance is being considered as a sine waves. So these sine waves, whereas digital signals are represented by square waves. So these are the square waves that are meaning for the digital. Now let us discuss this military the similarity of analog and digital signal. The best example of analog and digital signal is electrons, because it deals with analog as well as digital signals, input and output. In some way, an electronic project mainly interacts with by the real analog world, whereas digital signals with computers, microprocessors, and analog units. So the two kinds of signals are similar to different electronic languages, as some of the other languages can only recognize as well as speak one of the two. This article will discuss more about this. So now we're going in depth into showing you what the difference is. I've already described what the analog and the digital is. So an analog is one continuous time varying signal, and this is classified into composite and simple signals. A simple type of analog is nothing but a sine wave, which we have already discussed about. That can be decomposed, whereas a composite type of analog can be decomposed into numerous sine waves. An analog signal can be defined by using amplitude uh, and time period, the time period, otherwise frequency. So basically, I'm trying to tell you that the analog is defined by the amplitude and the time period, which is the frequency. So the amount of waves can be considered as the amplitude. This can be considered as the amplitude, then this can be considered as the frequency. Um, the amplitude strikes the height of the signal, and the frequency strikes the rate at which the analog signal is varying. So that's what you have basically showed you. Now the saying, similar to the analog, the digital signal carries the data through bits. Now, remember, I have overemphasized on bits binary. Binary deals with each and every machine which exists on this planet. Most of these big machines which are existing on this planet use binary. Any computer which computes anything uses binary. So bits is part of digital signal. It's part of the incorporation of digital. So whenever you see NS system which is digital, it contains binary, ones and zeros, each and everywhere, on and off. So basically, it's the same thing everywhere. So a digital signal carries the data in the form of binary because it signifies bits. These signals can be decomposed into sine waves, which are termed as harmonics. Every digital signal has amplitude, frequency, and phase like the analog. This signal can be defined by bit intervals and bit rates. So for for um, for the digital signal, we have they've said that we have the bit signal and the bit rate, the bit interval, as well as the bit rate. So here it is. Here bit rate is the here bit interval is in nothing but the required time for transmitting an only bit, whereas bit rate is an interval frequency. So this is the bit rate, this is the bit rate, and this is the frequency, bit frequency. So basically that's it. Now the next thing you have to know, I've already talked about the ones and zeros. The next thing I want you guys to recall is the differences. Now, they're saying the analog and the digital signals characterize mainly including adaptivity, continuity, representation, data type, signal type, medium of transmission, types of values, security, bandwidth, hardware. These are all the ways we can characterize them. Now, analog, adaptive. Analogs are less adjustable for range of views, whereas digitals are more adjustable. So that's one thing you have to realize, that you can easily adjust the analog, the digital compared to the analog. Then continuity. Analog signals use a continuous variety of amplitude values, whereas digital signals takes a limited set of distinct values as at consistently spaced spots in the time. So what I'm trying to mean is, analog is always taking in information at a continuous level, but digital is different. As you can see, it's more of like a wavelength. So it keeps on sending information. But for digital, it's different. So type of data. Analog signals are continuous in nature, whereas digital signals are discrete. So you can notice that there's a continuous flow, but for the digital, it's discrete. It's in a square format where things happen, be on, go off, be on, go off. So it's more rigid. Um, Medium of transmission. Analog signal medium of transmission is wire or wireless, whereas digital signals is wire. So basically what happens is, with the analog, there are two options of information transferring, either through the wires or wireless, as I've told you. But for digital signals, all these things which we are using, most of them travel through cable from Mombasa, like the internet. Um, the wires are running through Kampala and coming to us through those options. Then the information is sent digitally, analog, through analog to our computers and all that. And when we get them from the computer, we have to have a device which converts the analog to digital. And most of the times people use modems. Modems can be a very good tool for converting analog information into digital. So now security. The security of an analog is not encrypted. So encryption is one of those important things when it comes to whether it is developing apps, whether it is doing any other project or anything. Encryption is one way of securing your data to be safe. So for analog, information is not encrypted. That's why you see that people can easily tap any broadcasting station. When it comes to radio broadcasting, anyone who has a radio transmitter can easily connect to them. Even these walkie-talkies. These walkie-talkies, once you know the frequency the other people are on, you can easily communicate with them. So when it comes to analog, it is not encrypted at all. So it makes it vulnerable to attacks. Means that another person who is not supposed to listen to that information can always access it easily. So next thing is bandwidth. The analog signal bandwidth is low. So compared to this, so it being wired and wireless, analog, we know that wireless connections, most of them have a limited area to which it's supposed to handle. But now for the digital signal, it has to have, it's always high. Reason being, cables can run from one area to the other, then connect like that here and there. Now they're saying analog signals hardware is not elastic, whereas digital signal is elastic in exhaustion. Now, data storage. Data storage of an analog signal is in the wave signal form, whereas digital signal stores in the data binary bit form. So that one, I think I've talked about it enough times. When it comes to analog, everything travels to wave signals. So every information goes to the wave system. So then when it comes to digital, we've talked about binary. The whole of the time we were learning how to subnet, we were using binary. When we were starting, when we were doing classes in IP addressing, IPv4, we're doing binary. So binary should be part of you right now. So portability. Analog signals are portable. Yeah, basically, portability for analog is better because, uh, first of all, they're old systems, so the prices, first of all, are very low. That's why you're talking about low cost. Then, um, when it comes to portability, um, for portability, you find that most of the digital signals are starting to become more portable. But when it comes to prices, it's expensive. There's no, I'm yet to see an iPhone which is very cheap. But you get my point. These machines can want to be very expensive. Now, in the analog signal, the signal can be deterioration due to deteriorating due to the noise through. Yeah, basically, when you're transmitting data using the analog option, since you're using wavelengths, these different wave signals, uh, when they hit walls and all that, like the way we have, if you're using Wi-Fi, if you notice that when you're using Wi-Fi in a particular area, it can work very well. But if you exceed a particular area, it starts to losing its strength. So when it comes to analog signals, that's what happens the whole time. It ends up losing the the data as the more you're not near the particular area. So now power consumption. Analog devices use more power. So yeah, they use more power than data transmission rate. Yeah, the data transmission rate in the analog signal is slow, whereas the data in the data transmission in the digital signal it's faster. So since you're using cables in data digital, it means the information can come faster compared to the analog. If I remember showing you how we could use an Ethernet cable to connect to another computer, and they will be having a communication between the two computers. No, that's one way of demonstrating. If we had a very fast, if you have a very fast wire, like a Cat5, which is a 1 Gbps, it means that your information will travel at a very faster rate compared to someone who is connecting to my Wi-Fi and my phone is using the Wi-Fi. I mean, using the same service provider compared to also him. So there will be competition for the resources and all that. So that all comes into play. So now they're showing us the differences. The key differences: analog keeps changing, while digital is discrete. Analog has continuous sine waves, while digital are square waves. Then Let me first get back to that. And now we're saying digital signals is a square. Then analog describes discrete behavior of the wave with respect to amplitude, time, period, and phase, while this gives respect to bit rate and bit frequency, uh, the rate of bit as well as the bit interval. So, analog signal, you have basically looked at all this. This is just a compilation of the different things. Now, what I want you guys to do is to come up with another diagram like this, mentioning the analog and the digital signal, and you name for me the differences and the, the differences, plus you draw a diagram of the different types of signal, design of the analog and the digital signal, and how it can be transmitted, the devices which use analog and the ones which don't use analog. So that will be your task for this exercise. Now let's go to the next thing. This is what they, as we know, data transfer, there are different types of data transfer methods. As you'll notice, there are different types of data transmission. So this gives you a very quick, this I realize is a very good way of showing you how this thing looks like. So the first one is the simple data transfer. Now this one, the information comes from one direction to the other direction, and there is no vice versa or wait for this one to talk and you respond. So basically the simple duplex, which is the first one on my list here, is one directional information from the source to the destination. So basically information travels from one area to the other area and doesn't come back. So then the half duplex, have you seen this illustration here? This illustration here is for the simple duplex. Then the half duplex, next one should be the half duplex. Now the half duplex, now for the half duplex, when someone sends information, the other one has to first wait, then he receives, when the other one receives the information, can also send back the information. It's a one pipeline kind of information where when the pipe is under use, there's no way another person can talk to you. It's like those walkie-talkies where someone has to first talk and say Roger that, then the other one can speak. So that is what they call half duplex. So this is when you have to wait to send information if you are receiving, because both task of sending and receiving in a half duplex can't occur at the same time. Then for the full duplex, the full duplex is just basically like a modern phone. So what happens is you can easily communicate with one person easily. So this is the example of the half duplex. As you can see, the data moves from one area and comes back and goes back to the other. Now for the full duplex, you notice that the data is moving from both sides. It's basically like a normal telephone nowadays. Information is transferring to you and to another person like that. Yeah, this is exchanging information at the same time, at the same rate, You can choose to shout and also the other one shouts, and you can still both hear each other. That's the benefit of technology. So so basically that's it for today. I would like to thank each and everyone who has been there. I want to thank each and everyone for the good work they've been doing, and I hope to create more of these videos, and plus the group work. Um, for the group work, I'll be communicating to you guys, and I hope that you guys are ready, because for the front end development and the back end development and the testing, we shall focus on each area one by one, and basically we shall start building the skills starting from one section to the other section. Basically, if you know something, like right now you guys know front end is the HTML, the CSS, plus maybe you have to just brush up on JavaScript and all that. So I'll be teaching you those things out of my own time, out of my need for you guys to improve yourselves. So I want you guys to be patient with me and hope that things will work out. And I want to sign out and say thank you for a good job and hope for the best.